In this video, I'm going to talk about statistics. All right. Statistics is a branch of mathematics which deals with the collection, analyzing, representation, and interpretation of data. All right. Now let's use the ages of students in class 1. Okay. So we have 3, 4, 3, 5, 4, 3, 6, 5, 4, 3, 2, 5, 4, 3, 2, 2. All right, so let's see how we can interpret this data. All right, so let's get a table. So we have this side as ages. Okay, so all right, so let's start with the lowest age here. So we have 2. So we have 3, 4, 5, and we have 6. Okay, so let's go to the tally side. Tally is there. Okay, and we have the frequency. All right, so let's start. Okay, so we have 3. So let me go to the 3 side. 1 stroke, 4, 3, 5, 4, 3, 6, 5, 4, 3, 2. So 5, 4, 5, 4, 3, 2. So 3, the fifth I have to close it, then 2, then 2. Okay, so we have 3 strokes here. We have 5, we have 4, we have 3, and we have 1. All right. So knowing this one, we can interpret this data. We can talk about those below 3 years and those above 4 years. Now, if you're asked to write the number of students who are below 3 years, now this is 3 years, okay? So anything below is this. So we have 3 of them. And if you are asked to find the number of students who are above 4 years, we have 4 here. 2, 5, 6, and their frequencies are 3 plus 1. Okay, so we can interpret the data. So with the help of statistics, we'll be able to analyze this data very well. All right, so that's that. Okay, now let's talk about data. It is the numerical facts and figures from which conclusion may be drawn. All right, now we have 2 types of data. So data can be discrete. Okay, so when we talk about discrete data, we mean data which does not have values of decimals or fractions. A typical example is what we just did. So ages of students. So can I talk about 10 years, 15 years? Okay, so you can't say 10.5 years. No. So discrete data belongs to this class. Okay. So no decimal point. So that is discrete. Okay. All right. So we can also talk about continuous data. Continuous data. All right. Now with the continuous data, well, they have decimals or fraction. So we can talk about the height of students. So we can talk about 5.5, okay, meters. Okay. So continuous data is the opposite to discrete. So this one can have values of decimals or fraction. So you can talk about the height of students in class, the annual rainfall, okay, and what have you. That is that. Okay. Frequency. Okay. Now, when we talk about frequency, it is the number of occurrence of individual items belonging to a class or group. Okay. Now, we can have frequency distribution table. So we can have group and ungroup. Let's talk about the group data, then ungroup data. So all right, let's talk about group frequency distribution. Okay. Table. Now we have group and ungroup. Now let's observe the first one. We have marks. Okay. Now this one is not 10 minus 19. This one means the interval. So when you see this, it's an interval. So we mean 10 to 19. Okay. So when we're giving data like, let's say 10, 11, 12, 13, 16, 17, 18, 19. Okay. So from 10 to 19, that interval. Okay. That's the idea. All right. So when you see something like this, these ones are called grouped frequency distribution. So we have grouped frequency distribution. Okay. Grouped frequency distribution. Now let's observe the second one. We have 17, 18, 19, 20. Now there's no dash. Okay. There is no sign here showing that there is an interval. So this one is straightforward. So this one is called ungrouped frequency distribution. Ungrouped frequency distribution. So we now know the difference. All right. Class intervals. All right. Now, class intervals is a symbol which defines a particular group or class. So we have 5 to 9. So 5 to 9 is the interval. Okay, is a class interval. We can also talk about 10 to 14. Okay, so these are the class intervals. Okay, and we have the end values of the class intervals called the limits. So we have the limits. Okay, this one are called the limits. Another one here. Okay, so we call them the limits. Remember the first one, okay, here is called, or the smaller number here is called the lower limit. This one is the lower limit, and this one is called the upper class limit. Okay, so this one is called the lower class limit, then this one upper class limit. All right, that's that. So when you're given 15 to 19, So 15 is the lower class limit and 19 is the upper class limit. That's that. All right. All right, let's talk about the class boundaries. Okay. Now, when we're given a class intervals like this and you're asked to find the class boundaries. Now, let's pay attention. So, we have the lower class limits here. So, we have 5, 10, 15, 20. And we have the upper class limits 9, 14, 19, 24. All right, to find the class boundaries, first of all, we have to find a difference between the upper class limit of a particular class interval and the lower class limit of the next class. So, for instance, if I want to find the class boundaries, I'll just do this. Okay. So 9 here is the upper class limit of the first class. Okay. And the 10 here is the lower class limit of the next class. So what we are going to do is to find the difference. So we have 10 minus 9, which is 1. Okay. After that, you divide the result by 2. So 1 on 2 is 0.5. Okay. So what we are going to do after getting your result is to subtract the result here from all the lower limits here. Okay. So all the lower limits. So we have 5, 10, 15, 20. So you subtract the 0.5 from the lower limit. So 5 minus 0.5 will be 4.5. So 10 minus 0.5 will be 9.5. So 15 minus 0.5 will be 14.5. Then on this side will be 19.5. And guess what? We are going to do opposite to the upper class limit. This time we'll be adding the result here to the upper class limit. That is 9, 14, 19, and 24. So this side will be 9.5. So we have 14.5, 19.5, and we have 24.5. So these are the class boundaries. All right. Now let's observe something here. So we have, now watch, now this side. Okay. Guess what is happening? Okay. So this and that, this and that, this and that, I think they are equal. Yeah. All right. So these things should guide you when finding the class boundaries. All right. Okay. So let's talk about more examples. So when we're given this table, all right, so let's try this. Okay, you can pause the video, then give it a try. So we said you consider this. Okay, so we have 1.3 minus 1.2. Okay, so 1.3 minus 1.2 will be 0.1. And we said we divide the result by 2. So that will be 0.05. So we are going to subtract the result from all the lower limits here. Okay. So 1.1 minus 0.05. Okay. This side will be 1.05. Okay. Then 1.3. This side will be 1.25, and this side will be 1.45, and this side will be 1.65. Let's go to the upper as we add. So this side, if you add 1.2 to 0.05, it will be 1.25. So we have 1.25. This side will be 1.45, 1.65, 1.85. As simple as that. That is the idea of the class boundaries. Very, very important. Now let's talk about class size or class width, okay? Denoted by C, small c, okay? Now the class size is the difference between the lower class boundary, okay, and the upper class boundaries of a class interval. All right, now let's see how we can find the class size or class width. Okay, now remember, no boundaries, no class size. So without the class boundaries, you can't find the class size. So before you can find the class size, you should know the class boundaries. And we know how to do that. So this side will be this. Okay, so we have 10 minus 9 is 1 over 2 is 0.5. So we subtract 0.5 from the lower limits to get the class boundary. So we have 5, then we subtract 0.5, this side is 4.5, 9.5. Then we will add to the upper, so 9.5, and this side is 14.5. So let's create a column for the class size now that we know the class boundaries. So we have class size. Okay, so what we are going to do is to find the difference here. Okay, so we have 9.5 minus 4.5. Okay, so 0, so we have 5, so this side is 5. Okay, let's talk about the second one. So 14.5 minus 9.5, 0 point, so we have 5. So this side too is 5. So the class size here is 5, here too is 5. So remember that no class boundaries, no class size. That's that. All right. All right, let's talk about class mark or class midpoint. Or class. The class mark or the class midpoint is simply the average, okay, of the two class limits or the two class boundaries. So you can work from here or you can work from here. So once you are given the class mark and you ask to find the class, once you are given the marks and you ask to find the class mark or class midpoint, okay, you just find the average of these numbers. So we have 35, 39. So once you ask to find the average, you just sum them. 39 plus 35, then divide by 2. Okay, so we have 39 plus 35. So this side is 74 on 2. So we have 37. So this side will be 37. Okay. All right. We have 37 here. Now let's assume the frequency here is 5, 3, 4. Okay. Now the next one will be 44 plus 40. That will be 84. Okay. So 84 divided by 2 will be 42. Okay. So the next one will be 45 plus 49. So just find the average. So this side will be 47. So this side is a class mark. So denoted by X. At times when you ask to find the mean, okay, and you are given the class mark like this, so in an interval form like this, you need to convert this one to this before you can find the f of x, because this one is not x, these ones are just intervals, so we need to get the class mark or the midpoint. All right, so let's talk about the class boundary. So you can continue since we've already explained this in detail. So class boundary, so we said is the difference, okay, between this. So 40 and 39 is 1 over 2 0.5. We just subtract the result from the lower limits. So this side will be 34.5. So we have 39.5 and 44.5 from the lower. So the upper, we just add the result. Okay. So we have 39.5, 44.5, and 49.5. All right. Okay, so let's talk about the class size. We said no boundaries, no class size. So knowing the boundaries will help us get a class size. All right, so we have 39.5 minus 34.5. So this side is 5. Then 44.5 minus 39.5. So this side too is 5. 49.5 minus 44.5. This side too is 5. Now it's not always that the class size will be equal. Take note, okay? It's not always. At times you get unequal class size. All right, very important. Okay, let's talk about the mean. Remember, mean is one of the measures of the central tendencies. Very important. Okay, so the mean of a set of numbers, so x1, x2, x3 up to xn. Okay, so it's noted by x bar. So this one is the symbol for mean. So mean, so when you're given a set of numbers like this and you're asked to find the mean, is simply, so we have the sum of the items over the total number of the items. Okay, so when we're asked to find the mean of the following, so 1, 4, 2, 3, 5. Okay, so the mean of these numbers will be, so I'll sum them. 1 plus 4 plus 2 plus 3 plus 5 over the total number. So we have 1, 2, 3, 4, 5. So over 5. Okay. So 1 plus 4 is 5, plus 2, 7, plus 3, 10, plus 5, 15. 15 on 5. So 15 on 5 is 3. So the mean of these numbers is 3. So in short, the mean is given by summation of the items over the total number. So this is the formula for that. Okay. All right, let's try this. Okay, let's find the mean of these numbers. Okay, we have 1, 2, 3, 4, 5. So the mean is given by summation of the items over total number of items. So we have 37.2 plus. So let's put them together. Okay, so calculator 37.5 plus 38.9 plus 34.5 plus 29.5 plus 30.7. So we have 171.1 over 1, 2, 3, 4, 5. So 5. Okay. So when divided by 5, it will give us 34.22. Okay. So that is the answer for this. So just go ahead and try this. So we have 40.2, 44.5, 50.7, 39, 39.6, and 58.4. So just try this, and then you can put the answer under the comment section below. All right, let's observe this question. Now the mean of the numbers 5, 2, 3, x, and 9 is 4.8. Find x. So this one is very simple. So solution. Now remember mean. Okay, it's given by summation of the items over total number. All right, so the mean of the numbers here is 48. It means that the result is 4.8. That's the mean, is 4.8. And summation of x, so my summation of x here will be 5 plus 2 plus 3 plus x plus 9. So summation of x, we have 10, 19 plus x, and my n is 1, 2, 3, 4, 5. So we have 19 plus x over n. So we have 4.8 times n. So n is what? 5. That is 4.8 times 5. So this side will be 4.8 times 5 equals 19 plus x. So we have 24 equals 19 plus x. All right, so when we subtract 19 from 24, that would be x. Therefore, x is straight away 5. Okay, so this side is 5. 5 plus 2 plus 3 plus 9 divided by 5 give us 4.8. That's the idea. All right, so let's look at this question. Okay, so we are still under mean. The set of numbers x squared 3, 3x minus 4, 7, 9, where x is a positive integer, has a mean of 5. So find x. Okay, so remember mean is given by summation of x over total number. So the mean is what? 5. So we have 5 equals the summation of x. So we have x squared plus 3 plus 3x minus 4 plus 7 plus 9. Okay, on 1 2 3 4 5. 5. Okay, so as simple as that. 5 times 5 is 25. So we have x squared, so plus 3x, this and that minus 1, so 6, 15. Okay, so we have x squared plus 3x. All right, so we have 15 minus 25. So this side will be minus 10 equals to 0. Remember, x is a positive integer, it's a quadratic. So 5 to 10. Okay, and so we have minus 2, 5. So we have x squared plus 5x minus 2x minus 10 equal to 0. X out, x plus 5 minus 2 out, x plus 5, x minus 2, x plus 5 equal to 0. So equal this one to 0. So x is 2. And equate this one to 0, x will give you minus 5. Remember, x is positive. So we conclude that x equals 2. All right.